Hello, hello, hello. It is section 17, day 3 of comparing functions at different values. This is going to start on page 399 in your math book, so please open up to that page. Our learning target is the same as it has been, to compare properties of two functions, each represented in a different way. And today specifically, we're going to find and compare functions at different spots in time or different values. All right, so I'll show you what that means in just a moment. But as a quick recap, I've got 3 examples: always, sometimes, or never. What do you think? A, it says the function modeled by y equals negative 4x is an increasing function. Increasing function. What do you think? Well, that's never, because it is a negative slope. B, the function modeled by y equals x squared is an increasing function. Now that's called a quadratic function. It has an exponent there. So we're going to actually say sometimes. This is not something we're really working with, but we can say sometimes in this case because we haven't worked with that. And see, the function modeled by the equation y equals x plus 5 is an increasing function. That is always true because the slope is what determines if it's increasing or decreasing. That slope would be a 1, so it's positive. Now we're going to look at some functions that could be increasing or decreasing, and we're going to look at specific values or different spots in time. So today's problem of the day, why don't you read this through along with me. It says a silversmith compares the prices of jewelry making classes at 2 Native American studios. He finds Studio A on his phone, so that is right there. That's the Navajo one, and Hopi silver jewelry class. They charge $100 for initial fee and $25 per class after that. All right, and table B is shown, Studio B is shown in the table where we have the number of classes and then the total cost. What do you notice about these? What do you wonder? I think the one on the phone is a little bit easier to figure out your initial value and rate, but you can definitely figure it out from the table. Now the question asks, which studio should the silversmith attend if he has $200 to spend? So exactly $200, can't go over. Which studio? Studio A, which is on the phone, or Studio B, which is shown right here. So which studio should this, and then to question 2, which studio should the silversmith attend if he plans to take 15 or more classes? So this is question 1, and this is question 2. So let's answer those. Why don't you try those on your own first, but then let's answer those. So the way I would look at this is if I would answer number 1, my answer for number 1 would be, well, I can find 200. So Studio B, it's 5 classes for $500. $200, sorry. And Studio A, we don't know yet, but if we take the $100 plus 25, we could add that 4 times. 25 times 4 gets you another 100. That equals $200. That would be 4 classes. 1, 2, 3, 4. So that is 4 classes. So if I was choosing between Studio A and Studio B, I would go with Studio B because I get 5 classes out of it as shown in the table. Whereas in Studio A, all we would get, that should say A here, all we would get is 4 classes for that $200. Now, question 2 asks if they wanted to do 15 classes, which one should we pick? Well, 15 classes for Studio B is given. $15 classes for, it says up there, $500. It really adds up. Studio A, we have to figure it out. Now, if I do $100, that's my starting fee, plus 50, it's 25 per class, so 25 times 15. Instead of adding 25 15 times, I can just do 25 times 15. I'm going to grab a calculator or write this out, and 25 times 15 gets me $375. So that's 100 plus 375, which is $475 for 15 classes. So in that case, I would take Studio A because it's less money. So each one is a little bit different at different points because, first of all, they might start at a different starting value, and second of all, they might charge a different amount per class. And I can figure out my amount per class of Studio A because it's given right here on the phone, and Studio B I can figure it out by finding the rate of change. For instance, if it goes up from 80 to 200, that's up $120. Oops, 120 for 4 classes. My rate of change for Studio B would be, or my slope, I can write it like that, will be up 120 for 4 classes, which is $30 per class. So it's more expensive per class, but you start at a different initial value. So that's why, like if I go back, initial value would be $50. That's why if you do fewer classes, it might be better to do Studio B. More classes, it's going to end up being better for Studio A. But we can compare functions at different values in time. And some of the work that's shown that we just did is also shown on the next page. I'm going to jump straight to page, I think it's 401 now, where you start to analyze this problem a little bit and do another example or two. So look at both analyzes. For each question, decide whether the silversmith should choose Studio A or B. We did that. Number 2, what is the initial value of Studio A? That is given as $100 fee. What is the initial value of Studio B? That is, again, if I look back at this problem to find the initial value of Studio A, since I figured out, Studio B, since I figured out it's $30 per class, if I go back to 0 classes, I go back $30, and I'm at $50 for 0 classes. So it's a $50 initial value. So what does that initial value represent? The starting cost. Just to join. Now B says, what is the rate of change for Studio A? Again, that was on the phone. That was $25 per class. And what is the rate of change for Studio B? Well, we figured out from the rate of change in the table that it was $30 per class. And what does the rate of change represent? Well, it's the cost per class. We wrote that in there. So let's look at a different example, number 3. Actually, no, it's the same examples, but put on a graph. Studio A and Studio B are functions on the graph. I think this is the same example. Looks like it. So A says, for what number of classes is Studio B the better choice? If you look at Studio B, it's cheaper all the way up until this point. That's kind of the breaking point where now Studio B starts to be more expensive. So Studio B is a better choice up to 10 classes. For what number of classes are Studio B? That's the same class that is 10 classes. So for what numbers of classes is Studio A the better choice? Above 10 classes. Number 4, Studio A offers less expensive classes. Why is it not always the better choice? It's because of that initial value. Higher starting cost. That's why it costs more for the beginning at least. Number 5, do rates of change in initial values always provide enough information to compare two linear functions? In a roundabout way, yes. But we want to look at, sometimes we want to look at specific spots in time that's not shown just from those two things. So yes and no is my answer. Yes, but sometimes you need more detail. Like specific places in time. So let's just look at one or two other examples that follow a similar thing where we're looking at a specific spot in time. I'm going to jump to number 7 here. Number 7 shows Fadil and Luke have gift cards to their favorite diner. Fadil starts with $50 on his card. He spends $4.50 each day. The graph shows the amount Luke starts with on his card and the amount he has remaining on each day. Who has more money left on his card between day 0 and day 4? So Fadil, I spelled it wrong already. $50 minus $4.50 per day. So if we go 4 days, we want to figure out what it is after 4 days because we want to know between day 0 and 4. So after 4 days, I would do 50 minus $4.50. I'm going to multiply the 450 times 4 because it's 4 days. And I know 450 times 2 is 9, so it's minus 18. Or you can check that on a calculator and you get $32 after 4 days. Whereas Luke, you can look at the graph and at 4 days, we go up here. After 4 days, it says about, what is that? $25, $28, we'll say. It's definitely under 30. So who has more money left? The answer for that one is Fadil does. But it might not always be that case. I know Luke starts with less money, but I don't think it goes down by quite as much. So we're going to look at that a little bit farther. So look at the graph from problem 7. Suppose you graph the amount of money Fadil has on his gift card on the same coordinate plane. Which statement is true? Select all that apply. Well, let's look at this thing right here. It says the graph of Fadil's function is steeper than Luke's since negative 450 is greater than the absolute value of negative 450 is greater than the absolute value of 3. That is true because it's steeper because Fadil's is actually, he's losing more money faster. B, Fadil's card has a greater initial value than Luke's card. Well, Fadil's was 50, that's true. Luke's was 40. Both functions are decreasing, that is also true. They're both going down in amounts. Each day Fadil spends more on his card's money than Luke does. That is true. It's going down faster. And there's a day when the cards have the same value greater than 0. That's something we'd have to look at. It was close, like the 32 and the 28, but let's say we did after 5 days. So let's do 50 minus 450 times 5. So $4.50 times 5 would get me $22.50. So I would be at $27.50. And after 5 days, Luke would be down to 25. And I actually just started graphing it because it goes down $4.50 or $9 every 2 days. It actually will never cross on the same day at the same amount. So it crosses over at about that 7-day mark, but it will not. So let's look at more of any. Let's look at one last example. It says, look at problem 7. Who spends all of the money on his gift card first, Fadil or Luke? Well, you can figure out at so what I'm going to do is I'm going to take this and I'm going to write this as an equation. For Fadil, it is $50 he starts at minus $4.50 per day, and I want to know how long it's going to take to get to $0. Whereas for Luke right here, I want to know it's 40. He starts at 40 and goes down $3 per day, as we were said before, and I want to figure out when that equals 0. So what I'm going to do is I'm just going to solve this. I need to subtract 50 from both sides, get rid of that thing that's not attached to the variable, get negative 450 times the number of days equals negative 50. Divide by both sides by negative 450. And I get D equals whatever, negative 50 or positive 50 divided by $4.50. And it comes out to be 11.1 repeating days. So it's a little more than 11 days. So by the 12th day, it would be out. Whereas Luke, if I subtract 40, because I get rid of that, negative 40 equals negative 3D divided by negative 3. It'll be 0 when 40 divided by 3, which is 13.3 repeating days. So that means that Fadil's will run out faster, mainly because it's going down, spending more money each day. So that's just one example of when you can look at different spots in time and compare two functions to find, compare a different way other than using just simply the rate of change or initial value. But we're still using those things. So that's lesson 17, day 3 of comparing functions at different values. We'll see you next time.